Hey guys, this is Mr. Gordon here with Unit 4 Quiz 2, the video review for that quiz. So as promised today in class, as you saw on your handout today in class, I'm not sure why that blinking marker is there, but the quiz will cover finding cubic and quartic regressions given a graph of a polynomial. It will cover stating the degree of a polynomial, adding and subtracting polynomials, and finding the zeros of a polynomial. So let's go ahead and talk about what that looks like. So if I have a graph such as this, and I'm asked a question, what is the smallest possible degree of the function? I need to think about a property that we discovered in class with our first investigation. We discovered that the degree of a polynomial, or sorry, the number of zeros, or x-intercepts, has to be less than or equal to the degree. In other words, if I write that the other way, the degree has to be greater than or equal to the number of x-intercepts. So if I look at this graph, how many x-intercepts does it have? It has 1, 2, 3. So its degree has to be greater than or equal to 3. So what is the smallest possible degree of the function? Smallest possible degree is 3. Now, if I want to estimate the zeros of the function, I've already got started doing that. Zeros and x-intercepts are synonyms. So that first one clearly is at 0, 0. The second one, the middle one, is at 2, 0. So I have those two. And then finally, the last one, 5, 0. So we have 0, 0 right there, 2, 0 right there, and 5, 0 right there are x-intercepts. Now, part 3 says to estimate the local maximum and local minimum of the function. So let's start with the local maximum. So if I look for, remember, local maximum you can think of as turning points or peaks and valleys. So local maximum is a peak. So right here, this looks like a peak of my graph. So if I had to estimate the coordinates of that local maximum, it's not quite at 1. So maybe I'll say it's 0.9, comma, and it's not quite at 5. So I'll go with 0.9, comma 4. Now the local minimum, that's going to be a valley. So if I look at my graph for a valley, right there, let's call that 3.7, comma, how about -8? And again, we're estimating because I'm not 100% sure about those points, but best estimation, that's what I come up with. Now, if I want to find a polynomial function to model the graph, I now have 1, 2, 3, 4, 5 points I can use to model this polynomial. And I need to use a regression in the calculator. So I'm going to open up my calculator, go to home screen, new document, listen spreadsheet. So A column, that's my X, B column, that's my Y. So I've got 0, 0 was our first point, 2, 0 was our second point, 5, 0 was our third point, and then I had 0.9, comma 4, and I can't remember the last one, 3.7, comma -8. 3.7, -8. So now I have all my points. It's in the listen spreadsheet. So I press Control Doc to add a page. Now I want a data and statistics page. I set this as my x-axis on the x-axis, set that as my y-axis on the y-axis. And now we said the degree is 3, most likely. Right? It has to be at least 3. So let's start with a cubic regression. So degree 3 is cubic, regression, show cubic. That looks like a pretty good fit. So when I'm asked to write the equation for my regression, I'm just going to round to the nearest hundredth. Nearest tenth will be fine as well. So it's y equals 0.98 x cubed. That's coming from right there. And then we have plus negative 6.86 x squared. So I can write that as minus 6.86 x squared. That's coming from right there. Then I have plus 9.81x if I round. So plus 9.81x. And then let's see what the last term is. I have to click and drag. So that's 0.00, so that's just plus 0. So I don't even need to write that onto the end. And it makes sense that the y-intercept should be 0, because if I look over here, my y-intercept is in fact 0, 0. So that's a good rule. All right, so that takes care of local max, local min, finding zeros, and regression. Now the next part was adding, subtracting, and finding zeros, and stating the degree. So if I have two functions f of x and g of x as provided here, f of x is 3x to the third plus 2x squared minus 12x plus 10, and g of x is x to the fourth plus 8x cubed minus 10x squared plus 104x plus 105. The question is, what is the degree of each polynomial? So let's start with f of x. Remember, the degree is the value of the highest exponent. So when you think degree, think highest exponent. So if I look at f of x equals 3x cubed plus 2x squared minus 12x plus 10, the highest exponent I see is the 3. So the degree of f of x is 3. G of x, the highest exponent I see is 4. So the degree of g of x is 4. So degree is easy. It's just the value of the highest exponent. Now, what are the zeros of g of x? That's a bit more complicated. It requires me graphing g of x. So g of x is x to the fourth plus 8x cubed minus 10x squared. So I go to home screen, new document, save changes, no, add graphs. So I have x to the fourth power plus 8x cubed. So 8x to the third power minus 10x squared plus 104x plus 105. So let me just check that, make sure I type that in right. X to the fourth plus 8x cubed minus 10x squared plus 104x plus 105 looks good. So now we hit enter in order to graph that. So you can see I can't really see a great picture of it. So one thing we could try is menu, window, zoom fit. I do that, that zooms out way too far. So I'm going to press Control undo. And let me just change the window manually. Window settings. I know that I need to change my Ymin and my Ymax because that's where I'm having trouble seeing it. So let's just make our Ymin. We know the y-intercept is 105. So how about we go from negative 100 all the way up to 105. So maybe we can see a more full picture of this graph. Let me see, did I type everything right? X to the fourth plus 8x cubed minus 10x squared plus 104x plus 105. That's troubling. Well, maybe we don't have enough on our x. So I'll do analyze graph, window settings. I'll change my x-min to negative 20 and my x-max to 20. Hmm. Okay, apologies there. So I had to go back and get my notes. I realized I originally typed this wrong. It should be minus 8x to the third. So now I can go back into my calculator, press tab so I can edit my equation, arrow up to get back to it, and then I change that from a plus to a minus. And there's the graph I was looking for from the beginning. So menu, analyze graph to find the zeros. So to find the first zero, I have to click to the left of it for the lower bound, and then to the right of it, but not too far to the right for the upper bound. So you can see there it is, -3 comma 0. Then I repeat the process for every other x-intercept. So those two are too close together. So I'll drag them out. So we have -3 comma 0, -1 comma 0, analyze graph 0, 5 comma 0, and 7 comma 0. So -3, -1, 5, and 7. Those are the zeros of g of x. -3 comma 0, -1 comma 0, 5 comma 0, and 7 comma 0. And remember earlier we said that the number of x-intercepts has to be less than or equal to the degree. We said the degree of x is 4. This is 4 x-intercepts, so it works out beautifully. Finally, you will be asked to add and subtract functions. So if I want to do f of x plus g of x, that's fairly easy. So I'll just take f of x and bring that down. I'm feeling lazy, so I'm going to hit that copy paste. So bring f of x, and then I'm going to take g of x, bring that down. Now, I want to do f of x plus g of x. So notice I'm stacking them just like when you were asked to add 101 plus 317 back in the day. You stacked them, 101 plus 317. Same thing here, but with polynomials. So I'm going to take these two terms and I'm going to add them. So here is like 0x to the fourth. There's no x to the fourth term. So when I add 0x to the fourth and x to the fourth, I get x to the fourth. Now 3x cubed plus 8x cubed, that gives me plus 11x cubed. 2x squared minus plus -10x squared, or 2x squared minus 10x squared is minus 8x squared. -12x plus 104x, that is -90 or positive 92x. And then 10 plus 105 gives me plus 115. So that is f of x plus g of x. We're just combining like terms basically. And this is another way of looking at it by stacking it. Looks good. Now, if I wanted to subtract, it's a bit of a different story. So let's do f of x minus g of x. So I'll clone f of x, bring it over, and then clone g of x. Not delete g, man. Clone. So we want to clone that. Cool. Bring that over. Now, here I am subtracting. So I'm subtracting, but I'm subtracting this entire quantity, this entire polynomial. So we said in class when I'm subtracting, I have to distribute the -1, and then it will become addition. So when I distribute the -1 out here, it changes every single value in parentheses. So I'm going to rewrite the problem. So f of x is still the same, 3x cubed plus 2x squared minus 12x plus 10. Now this becomes minus x to the fourth minus 8x cubed plus 10x squared minus 104x minus 105. Every sign changed. And now we can think of it as addition, and we're just combining like terms. So this is negative x to the fourth because I have 0x to the fourth minus x to the fourth. Then 3x to the third minus 8x to the third is negative 5x to the third. 2x squared plus 10x squared is plus 12x squared. Negative 12x minus 104 is negative 116x. And then 10 minus 105 is minus 95. So that's what you get when you subtract the two polynomials, and that wraps up our Unit 4 Quiz 2 review. I wish you guys the very best as you study for the quiz. And I'll give you an extra credit code just for looking, which is, um, let's see, Lake Wiley, which is outside of Charlotte. There's your extra credit code for the quiz tomorrow.